Hello everyone, this is Miss Lindsay. Today we're going to talk about areas of parallelograms, rectangles, and squares, as well as introduce Brahmagupta's formula. Let's just dive into parallelograms. The formula for finding the area of a parallelogram as well as a rectangle and square is base times height. Now let's talk about the relationship between the base and the height. The base can be any side. And I'm going to jump down here to a rectangle. We typically would say the base, we look at it as the bottom, but it doesn't have to be, and the height is the side. Well, why is that the case? That is because the relationship between the base and the height is that it's a perpendicular. Same thing over here with the square. We write base times height. We would simplify that to sides squared because the relationship between the sides is the perpendicular. So in other words, we're looking at the altitude. So when we're talking about a parallelogram here, we can have base, then we would draw down the perpendicular, and that would be the height, or in other words, the altitude. So if I did draw another figure over here and I called this the base, I could then, I did not draw that very well, let me redraw that. So now if I have a parallelogram and I want the base to be this side, I would then have to draw the altitude perpendicular to that, and therefore that would be my height. So base doesn't necessarily mean bottom. That's how we traditionally look at a picture. But a base can be any side, and the height is the altitude that perpendicular to that side. So let's go ahead and do a few examples here. So moving on to the first one here, find the area of the parallelogram. So in this case, 19 definitely is the altitude to the base of 15. So it's simply 19 times 15. And we'll get to 85, and we want to make sure we label that. In this case, we're talking about areas, so we're talking about square units, so that would be meters squared. Moving on to the second example, this one is a little bit different. We're trying to find the area of each shaded region, so we have in this case a larger square, and then we have smaller squares within inside of this. So there's a couple different approaches we can take. We can take either the larger the area, we can take the area of the larger square and subtract the 4 smaller ones, or we can find the area of each of these individual little shaded squares and find them. I'm going to go ahead and do the larger one, so I'll do the area of the larger minus, I have 4 congruent non-shaded regions that I'm going to do there. So non-shaded. So in this case, I have the dimensions of the larger one would be 14 by 14. So 14 by 14 minus each of these are 5 by 5, and I have 4 of them. So when we go ahead and calculate that, we would get 196 minus 100, 96, and we're going to go ahead and label that as well, meters squared. At this point in time, I would like you to go ahead and pause the video. I would like you to go ahead and answer number 3. And when you're ready, answer, and then you can resume. Okay, moving on to example number 5. So here we have a rectangle is 6 meters longer than it is wide. Always a great idea to draw the picture. So I have a rectangle, going to label 6 meters longer than it is wide. So if I call that W, the length would be 6 plus W. The area is 315. So area is 315 square meters. Length times width, base times height. So we'll take 6 plus W times W would equal the area of 315. We go ahead and distribute there, W squared plus 6W equals 315. And now we have a problem that we would like to go ahead and factor. So we would factor that. factors of negative 315 that add up to 6, and that is positive 21 and negative 15. So we get W value of negative 21 and positive 15. We cannot have a negative length, therefore negative 21 would not work. We want to find the length. We found the width to be 15 meters. If we add 6 to that, we get that to be 21 meters. Okay, I would like you to also pause the video at this point in time and answer question 6. Once you have done that, then you can continue on. Okay, moving on to Brahmagupta's formula. Brahmagupta's formula tells us how to find the area of inscribed quadrilaterals. So if I have a circle, I can then take a quadrilateral, whatever that may be. I have sides A, B, C, D. My B does not look very good. Let me redo that. So what I would do with those sides is I would find what we call S, the semi-perimeter. I would add just exactly what you would think. You would take the perimeter and divide it by 2. So with the semi-perimeter, the actual formula for Brahmagupta's is square root minus A, S minus B, S minus C, and I'm running out of room, so let me go ahead and move a couple things here. And then S minus D. So take the semi-perimeter, subtract each side, multiply them together, and then take the square root of all of those. So let's go ahead and try this first example here for Brahmagupta's. We want to find the area of an inscribed quadrilateral with sides 2, 4, 5, and 9. So our first item of business is to find, and I apologize, I don't know why these screens keep showing up, but S equals 2 plus 4 plus 5 plus 9. So the perimeter divided by 2, which gives us 10. Okay. Once we find that, then we can actually find the area by taking that semi-perimeter, subtracting each of the sides, and then multiplying those all together. So we get square root of 8 times 6 times 5 times 1. That would equal square root of 240. And of course we want to reduce that. That would reduce to 4 square root of 15. It doesn't give us a unit of measurement, so we'll label that units squared. Okay. For class tomorrow, I'd like you to take a look at this question, number 7. It says the vertices of square MNOP are the midpoints of square ABCD. Explain why the area of ABCD is twice the area of MNOP. And this is supposed to be shaded in just to highlight that square in the middle. I know it looks a little bit different there. The shading did not turn out well. But contemplate this, come in with the answer tomorrow so we can have a discussion about it in class. And this concludes areas of parallelogram, rectangles, squares, and Brahmagupta's formula.